Hey guys, in today's video, we are going to be talking about algebraic expressions. Let's start off by defining what an algebraic expression is. An expression is a group of terms which are separated by plus or minus signs. So, I've written here the expression 2x plus 3. As you can see, there is no equal sign. If I were to add an equal sign, and let's say this equals 5, I no longer have an algebraic expression. This is now classified as an algebraic equation, because remember that equal sign turns this into an equation. The purpose of algebraic equations is to find the value of x. But for this video, we are not trying to find the value of x. We are going to be simplifying expressions which will look like this. So let's get into some examples. For question 1, we are asked to simplify the algebraic expression 6 plus 3 times x minus 2. Now remember, we start off by multiplying the 3, which is the number outside the brackets, by the numbers inside the brackets. So we need to multiply 3 by x as well as 3 by negative 2. This is one of the first rules of BODMAS. So we start off, and since the 6 does not affect the multiplication, we can keep that there. Next, we're going to multiply 3 by x, and that is going to give us 3x. Next, we multiply 3 by negative 2, and that gives us negative 6. Alright, now that we have multiplied everything out, our next and final step is to identify all the like terms and let them interact with each other. So we can see that 6 and minus 6 are both constants, so they can interact with each other. So 6 minus 6 is simply 0. And since 3x does not have any like terms, it will not interact with anything, so he will stay the same. Therefore, our final answer for question number 1 is 3x. For question number 2, we're once again asked to simplify the expression 5x minus 2x times x plus 2. Once again, we're going to need to multiply this minus 2x by the x, as well as this minus 2x by the positive 2. So we can start off. The 5x has nothing to do with the multiplication. Next, minus 2x times x will be minus 2x squared, because x times x is x squared. Lastly, minus 2x times positive 2 will give us minus 4x, because minus 2 times positive 2 is minus 4. Lastly, we need to identify the like terms. We can see that this term, 5x, has got an x, and this term, minus 4x, also has an x. Therefore, 5x minus 4x is simply 1x, which we write as x. And since minus 2x squared does not have any like terms, there are no other terms here with an x squared, so we keep that, and it does not change. Lastly, we must always remember that it is best to write our expressions out in descending order of variable power. So, since this term has an x squared, whereas x is simply an x to the 1, 2 is greater than 1, therefore we know that we're going to have minus 2x squared plus x. And that is our final answer for question number 2. For question number 3, we're once again asked to simplify. I'm not going to read all of it out because I'm lazy, but remember, we're going to need to multiply that 5 by the first term as well as the second term, and then we're going to need to multiply the 2 by the first term as well as the second term. So let's do that. First, we're going to have 5 times 2a. 5 times 2 is 10, and we keep the a. 5 times minus b will give us minus 5b. Next, we will have 2 times 3b, which is plus 6b. And then lastly, we will have 2 times minus 4a. So 2 times minus 4 is minus 8. So we will have minus 8a. Lastly, we now need to have a look at our like terms. So here we've got 10a, and we see that this term also has an a. So we can let these two terms interact. And 10 minus 8 is 2. So 10a minus 2a will be 2a. Next, we have minus 5b plus 6b. 6 minus 5, or minus 5 plus 6 is 1. So minus 5b plus 6b will give us 1b, which we can just write as b. And that is our final answer for question number 3. For question number 4, we're once again simplifying. And what's going to happen is this is going to be multiplied out, and we're going to get something. We're then going to add that to this once that has been multiplied, and all of that will be added onto that final term. So let's get into it. 4a times a gives us 4a squared, because remember, a times a is a squared. 4a times b gives us 4ab. Next, we have minus 2b times 3a. That gives us minus 6ab. Then we say minus 2b times minus 5b. Minus 2 times minus 5 gives us positive 10. And a, or rather b times b, gives us b squared. And lastly, we need to add that final term. So now we can have a look at all of our like terms. So firstly, we've got 4a squared, and we see that there are no like terms for 4a squared. No other term has a squared, so we can keep it. Next, we're going to have a look at all the terms which have ab. We see that we've got 4ab minus 6ab plus 2ab. So 4 minus 6 gives us minus 2, plus 2 gives us 0. So with that, we can see that these terms are going to cancel out and give us 0ab. So we don't need to write anything more. Lastly, we can see that we've got 10b squared. There are no like terms for this term, so we can write it in. And this is our final answer for question number 4. I'm going to get right into question 5, as you should already know how the multiplications are going to happen. So we start off and we say 2 times 3x squared will give us 6x squared. 2 times 6x gives us 12x. And then remember, we've got another term, so we need to say 2 times minus 1, and that gives us minus 2. Now for the next set of brackets, we see we've got a minus in front of them, and remember, this is simply just a minus 1. So we can say a minus 1 times 2x gives us minus 2x, and minus 1 times minus 4 gives us plus 4. Now is our final step, and we need to look for like terms. So since there are no terms which are similar to 6x squared, meaning there are no terms which have an x squared. We simply leave this term alone. Next, we need to have a look if there are any terms which have x's in them. And we see we've got 12x and 2x. So we can say 12 minus 2 is 10. Therefore, 12x minus 2x gives us 10x. And that was a positive. Lastly, we have a look at our constants. So we've got a minus 2 and a plus 4. So minus 2 plus 4 gives us plus 2. And that is our final answer for question number 5, as we have dealt with each of the terms in this expression. For question 6, we are multiplying two binomials by each other. Now remember, these are called binomials because inside the brackets we have got two terms, where bi means two. When we are multiplying binomials, we need to remember the acronym FOIL, where each letter stands for something. The F stands for first, meaning we're going to multiply the first term of each of the binomials. The next letter, O, stands for outer, meaning we're going to multiply the outer two terms of this binomial. Our next letter is I, which stands for inner, meaning we are going to be multiplying the inner two terms by each other. And lastly, we have the letter L, which stands for last. And this means that we're going to multiply the last two terms by each other. So let's do that. So for F, for first, we need to multiply 2a by 4c. So 2 times 4 gives us 8, and a times c gives us a c. Next is O for outer, so we're going to multiply 2a by 5d. 2 times 5 gives us 10, so that becomes 10, and a times d is a d. Next is I for inner. We're going to multiply negative 3b by 4c. Minus 3 times 4 is minus 12. B times c is just bc. And lastly, the letter L, which stands for last, means we're going to be multiplying minus 3b by positive 5d. Minus 3 times 5 is minus 15. B times d is simply just bd. Now, our last step is to look at this expression and see if we can simplify it. As you should all note, we cannot find any like terms, right? So that means that this expression is already in its simplest form. We cannot simplify any further, and we have our final answer for question number 6. For question number 7, we are once again multiplying binomials. So we start off by saying 2x times 3x, because remember, we are using FOIL, and the first letter is F for first, so we're multiplying the first two terms. So 2 times 3 gives us 6, x times x gives us x squared. Next is the letter O, which stands for outer, so we're going to be multiplying the outer two terms, which are 2x and 5. So 2 times 5 gives us 10, and we need to remember the x. Next comes the letter I, which stands for inner, and that means we're multiplying 1 by 3x, which will give us 3x. Lastly, we have the letter L for last, so we're multiplying 1 by 5, and that will just give us 5. Our final step is to identify all the like terms, and as we can see, the only two like terms we have will be 10x and 3x, so we can add them up together to get 13x. So since 6x has no other like terms, we don't do anything with him. We can then add 10x to 3x to get plus 13x. And there are no other constants, so we just leave that alone, keep it at the bottom there, and that is a final answer for question number 7. For question number 8, we have a slightly more interesting scenario. As we can see, these two binomials are almost identical, except for the fact that here we have a minus and here we have a plus. But otherwise, the terms in each of the binomials are exactly the same. This scenario is referred to as a difference of two squares. And when we are multiplying with a difference of two squares, there is a bit of a trick. Our final answer is simply going to be the first term squared minus the last term squared. So, if we square the first term, that'll give us 49, and I said minus, and now we square the last term. So that'll be y squared. But let's actually multiply this out and see if we get the same answer. So when we apply FOIL, we're going to multiply the first two terms and get 49. Next, we're going to multiply the outer terms. So 7 times positive y, that gives us plus 7y. Next, multiplying the inner two terms, minus y times 7 gives us minus 7y. And lastly, we're going to multiply minus y by positive y and get minus y squared. Alright, we then look for our like terms and see that we've got plus 7y minus 7y. Plus 7 minus 7 gives us 0, so we can cancel these two terms out, which means that we are going to be left with 49 minus y squared. And would you look at that? That is exactly what our rule told us we were going to get. So that is our final answer for question number 8. For question number 9, we once again have a difference of two squares, because both terms in the binomials are exactly the same, and we just have different signs inside. So remember what our rule said? It was square the first term, so we say x squared. Next, we minus, and lastly, we're going to square our second to last term. Right, so 3y squared, 3 squared is 9, y squared is obviously y squared, and that will be our final answer for question number 9. If you're unsure about how or when to use this rule, don't worry, you can still use the original FOIL method, where you multiply the first terms and then the outer terms and the inners and the lasts, and you'll still arrive at the same answer. This is just a little bit of a shortcut when you've got a difference of two squares. For question number 10, we have two binomials which we are squaring, and then we are adding these squares together. Now, one way to approach this would be to actually write out these binomials and then perform the multiplication, which we have been doing all along. That would be one way. However, there is another trick which we can use to square binomials. This trick can be used to any binomial which is being squared. So let's say, for example, we had the binomial a plus b, and we wish to square it. The rule states that we need to square the first, so we square the first term. We then multiply the two terms by each other and double it. So we will have a times b, and since we're doubling it, it will be 2ab. So 2ab and then we square the final term, so we'll have b squared. If you're not sure about this, we can then explain even further and get a plus b times a plus b. FOIL would say that we multiply a by a and get a squared. We would then multiply a by this b and get plus a b. We then multiply the inners and get a b once again, and then we'd multiply b by b and get b squared. This can then simplify to a squared plus 2ab plus b squared. So as you can see, instead of multiplying it all out, we simply apply this rule and we don't need to multiply out. It's a nice little trick that we can use to save time. Once again, if you are uncomfortable with understanding how to use this or when to use this trick, don't worry, you can still write out the binomial and multiply it out using the FOIL method. You will still arrive at the same answer. I'm just showing this trick as an alternative. So by using the trick, we are going to square the first term. So we're going to get x squared. We then are going to multiply and double. So x times 3 gives us 3x. We then double it and get plus 6x. Lastly, we need to square the last term, so we say plus 9. For the second part, we can use that same trick. We square the first term to get 4x squared. We then multiply and double, so 2x times 1 is 2x. Double it to get 4x. And lastly, we square the last term. 1 squared is just 1. Alright, so we have saved a step. We've saved ourselves a bit of time by using that trick. Lastly, we need to look for like terms. So we see that we've got two terms which have an x squared, so we can add them together. Remember that there's essentially an invisible 1 in front there. So 1x squared plus 4x squared gives us 5x squared. Next, we're looking at the terms which have x's. 6x plus 4x will give us 10x. And lastly, we're going to have a look at the constants, which are 1 and 9. So 9 plus 1 gives us 10. And that is our final answer for question number 10.